How is it that some technicians seem to instinctively know where to look in order to quickly diagnose an electrical problem? The answer is years of experience, a thorough understanding of how the various vehicle systems operate, and a good diagnostic process that allows them to work efficiently. Most efficient electrical troubleshooters work methodologically, whether they are aware of it or not. They only check the components that can cause the problem and perform all the easiest checks first. This course will introduce the 5 steps of an efficient electrical troubleshooter, which are: verify the complaint, determine the related symptoms, analyze and isolate the faulty circuit, fix the problem, and test for proper operation. As you gain experience, you will most likely adapt or combine some of the steps to better suit your style and work environment. Remember that part of being efficient is being able to adapt to the information at hand. In this course, we'll be simulating a typical electrical problem and following the 5-step process to troubleshoot it. These steps should be applied to any electrical problem that you may encounter. This training video will outline one of the simplest troubleshooting guidelines to follow. This 5-step troubleshooting guideline should be used for all your troubleshooting needs and can also be applied for non-electrical issues. Imagine that you've just been handed a work order with 2 customer complaints. The first step in the diagnostic process requires you to be able to identify and reproduce the customer's complaint. It also means that you have to determine if the complaint represents a problem or not. And finally, if there is a problem, you need to determine if it is continuous or intermittent. Take the time to fully understand the issue the customer is facing. It's possible that the description of the complaint on the work order isn't described the same way you would. Clients often have difficulty communicating the issue that the vehicle is having. The situation can also be made worse if the work order doesn't include enough information to guide your efforts. For you to work efficiently, there needs to be a clear description of the complaint and any symptoms on the work order. It is possible that what may appear to be a problem to a customer may actually be a normal behavior for the vehicle. It's your responsibility to know the vehicle and systems well enough to be able to determine if the complaint is founded or not. If in doubt, refer to the operator's guide on the general system description in the shop manual. These resources clearly explain what should happen in various circumstances. If you are able to verify the complaint and have determined that a problem exists, you're ready to move on to step 2. However, if you cannot duplicate the complaint, you're probably facing an intermittent problem. If possible, put the unit aside and have the customer show you the problem at a later time. You can also call the customer yourself, explain the tricky situation, and get the necessary information that will allow you to reproduce the problem. Intermittent problems require as much information as possible on the conditions that exist when the problem is there. You should use the BRP Intermittent Fault Checklist as a guide to gather as much information as possible. Remember, you cannot diagnose or repair a problem that you cannot reproduce. Swapping parts just to see what happens will usually result in wasted time and money for everyone. Sometimes, several complaints are related. It's also possible that there is a problem that the customer hasn't noticed or isn't complaining about. Looking for and finding any other issues will usually help you narrow down the list of potential problems. Looking for related symptoms enables you to concentrate on common components. Try using as many related and unrelated systems on the unit and look for anything that isn't working normally. It's possible that the ECM has also noticed the problem that the customer is experiencing and has already set a fault. You should be happy when you find a fault code because it guides your troubleshooting, so use it as a tool. The tools required to complete this procedure are the ECM adapter, multimeter, T-harness, test light, and spark tester. To find the cause of an engine performance problem, you're going to have to use all the information available to you in order to quickly pinpoint and isolate the faulty system. Performance problems can typically be either mechanical or electrical in nature. A mechanical problem can include low cylinder compression or excessive combustion chamber leakage, restricted exhaust or intake airflow, incorrect cam timing, or any other mechanical failure that can affect combustion. An electrical problem may be rooted in the electrical system, ignition system, the fuel system, or the engine management system, or EMS. Check for fault codes and update modules as suggested by BUDS 2. In our example, BUDS 2 is displaying two fault codes: P0302, a misfire on cylinder number 2, and P0352, a problem in cylinder number 2's ignition coil circuit. Just like customer complaints, sometimes two or more faults can be related. Always ask yourself what the faults have in common, or if one fault can cause the other. In this case, a faulty ignition coil circuit can cause a misfire on the same cylinder, but a misfire cannot cause a faulty ignition coil circuit. When it's time to start testing components, always focus your first efforts on the component or system that is more likely to be the root cause of the problem. Both of the fault codes point to a problem with the ignition system. A fault in the ignition system can definitely cause the vehicle to lack power during acceleration. The next step will be to determine how much of the system of circuit is affected. As soon as you suspect that you are dealing with an electrical system problem, it's time to consult the wiring diagram found in the shop manual. Identify the components in the ignition circuit for cylinder number 2. There's a fuse, the HIC connector, which connects the chassis harness to the engine harness on all BRP products, the ignition coil, and the ECM. As a tip, we suggest you use the color diagram on the Knowledge Center. It will save you time. Color diagrams identify power, ground, signals, and other useful information that make them easier to interpret correctly. Look for other components on the same circuit. All of the ignition coils are on the same circuit. Use this information to determine if the entire circuit is affected or just a part of it. Now that we've confirmed the complaint, mapped out the circuit, and gathered all the necessary information, we're ready to start testing. Remember to always check the easiest components first. Diagnosing a problem is a process of working methodically and eliminating possible causes. Some circuits will be easier to test than others. Usually, the easier a connector is to reach, the easier it is to test. If you've mapped out a circuit with easy-to-reach connectors, you might want to try the split-half method. With this method, you make the first test in the bad circuit near its midpoint. The idea being that if the circuit is good or bad at the midpoint, you've just isolated the faulty half of the circuit and eliminated the other half. Diagnosing a problem is a process of elimination. Use your understanding of the wiring diagram and electrical testing methods such as voltage drop tests, resistance checks, voltage measurements, or ground checks to determine the most appropriate type of test to use. You would now continue to apply the split-half method to the remaining bad half of the circuit until you locate the cause of the problem. Working from power to ground is probably the most common way of approaching electrical diagnostics, as there's no jumping around the circuit. However, if you have noted that several problems on the unit have a common point, you should start the inspection at that point. And you should always start testing at the easiest access point or at a component that has a history of repeated failure. Let's take a look at each component and see if it can be the cause of the complaint. The fuse may be burnt, but if it was, there wouldn't be battery voltage to any of the ignition coils. In other words, the engine wouldn't run. On this vehicle, all engine coils receive power from the same fuse, so we can rule out the fuse as a possible cause. Now that we know the fuse is good, it's time to make sure that power is available at the ignition coil's connector. The wiring harness could be shorted. Check for power at the ignition coil connector when the unit powered up. The pink line on the wiring diagram indicates that the ignition coil should receive a switched 12 volts at pin 3. Measuring 12 volts at this point indicates that the harness does not appear to be at fault. Please note that when probing connectors, make sure not to open the terminals. This can create intermittent problems that are very difficult to locate. Also, be careful when back probing sealed connectors. Damaging the wire seal will allow water to enter and corrode the terminals. Try using a universal T-harness, also called breakout leads, inserted into the terminals. Using the correct T-harness will allow you to accurately perform the test without damaging the terminals or seals. Here's a tip. If you suspect a problem in the harness, gently wiggle, push, and pull on the harness to see if any of the readings change on the multimeter. The next suspect component to test is the ignition coil. Since an ignition coil is easily disconnected, now is a good time to measure resistance. The shop manual provides specifications for measuring the primary and secondary windings of most ignition coils. Here's another tip. Although a component should be replaced if the resistance is out of specification, a measure within specifications does not guarantee that the component is performing as it should. One last thing to check: the ECM and wiring to the ECM. This is where you have a choice. You can either swap ignition coils between the faulty cylinder and a known good cylinder, or you can check the wire between the ECM and the ignition coil. The choice will often depend on the vehicle. Whenever possible, swap coils because this step will confirm the diagnostic and the correction at the same time. If the vehicle only has one coil pack, you will need to test the wire to the ECM. Here's one last tip. If you have an oscilloscope, you can view the waveform on the power control circuit by back probing the ignition coil connector and using buds to activate the ignition coil. This is an easy way to ensure that the ECM is properly controlling the ground side of the primary coil. The blue tracer line shows the voltage in the circuit dropping from battery voltage to 0 volts when the ECM switches the ignition coil control circuit to ground. Once you swap the coils, you can either reassemble everything, clear the fault codes, start the engine, and see if the misfire fault moves to another cylinder. Or you can install a spark tester on the coil and use buds 2 to activate the ignition coil. If the known good coil works on cylinder number 2, and the suspect coil doesn't work when installed on another cylinder, then the problem is definitely the ignition coil. In this scenario, if you cannot swap coils, disconnect the ECM-A connector and install the ECM adapter tool on it. Use the multimeter to measure the resistance between the ignition coil connector terminal 1 and the ECM-A connector terminal M2. Finally, now that you have confirmed that there is a misfire in cylinder number 2 caused by a faulty ignition coil, don't forget to check for any collateral damage, or in this case, a fouled spark plug. This is a particularly important step. Sometimes one problem causes another. Always see the diagnostic process through to the end. In this case, it isn't enough to stop at the ignition coil. It is possible that even a good ignition coil will not be able to fire a spark across a fouled spark plug. A faulty ignition coil caused the initial complaint. The misfire also created a rich condition inside the combustion chamber and fouled the spark plug. The owner was complaining about a lack of power during acceleration. The defective components can most definitely be the cause of the owner's complaint. At this point, you should be confident preparing an estimate to replace the ignition coil and the spark plugs. As you know, this will fix both the symptoms and the cause of the customer's complaint. Now, it's time to prepare a parts and labor estimate and contact the vehicle's owner. Rephrase his complaint to make sure you are both talking about the same thing. Explain that you were able to reproduce the problem, confirm his complaint is real, pinpoint the cause, and explain that you have prepared a detailed estimate for the repair. Once he has agreed to the repair, proceed with the correction. Use the shop manual and follow the repair procedure. You can also search the Knowledge Center and community for tips from other technicians on performing the repair. Once the repair is complete, it's time to test the unit under the same conditions that you used to confirm the complaint at the beginning of the diagnostic process. This is the only way to make sure that the unit is fixed and that the customer will be satisfied with the repair. Part of the process is to never assume that there is only one problem. For example, a fouled spark plug can be caused by a rich mixture in the combustion chamber because of a defective manifold absolute pressure sensor signal, in which case replacing the fouled spark plug would only fix the symptom and not correct the root cause of the complaint. If in doubt, or feel as if you cannot find the root cause of the complaint, try creating a web case to see if others have had similar problems. In summary, the entire process can be broken into 3 sections, often referred to as the 3 C's. The complaint comes first. This is often the reason why the vehicle is at the shop in the first place. The next step is to methodically test and eliminate all potential causes of the problem until you are left with the root cause. And finally, once you have repaired or replaced the defective component, make sure that you have corrected the owner's complaint. Following the 5 steps as outlined in this course and making sure you have addressed the 3 C's will make your next troubleshooting experience a piece of cake.